Okay, let's get started. Welcome to What's Next on AWS On Air. Today we'll be talking about AWS IoT Core for LoRaWAN. I'm Yubo Wang, Senior Developer Advocate of AWS, and I have invited two guest speakers to join our sessions. They are Priyanka and Karthik. Welcome. First, can you make a quick self-introduction of yourselves? Priyanka first.
Thank you, Yubo. We're very excited to be here. Hi, everyone. I am Priyanka Jindal. I am a Senior Product Manager with AWS IoT. And welcome to our session.
Thank you, Yubo. My name is Karthik Ranjan. I'm part of the AWS Partner Network IoT team, and I work on LoRaWAN ecosystem. Super excited to be here today.
Thank you. As we know, we have announced AWS IoT Core for LoRaWAN, which is a new fully managed capability that allows AWS IoT Core customers to connect to LoRaWAN. First, I think I'd like to know more details about for LoRaWAN. First, I'd like to ask Priyanka, what are the benefits of LoRaWAN versus other types of connectivity?
Yes. So LoRaWAN stands for Low Power Wide Area Network Technology. And today, enterprises across a wide variety of industries and verticals, from agriculture, smart home, buildings, supply chain, industrial control, have a requirement to develop IoT wireless applications using devices that can transmit data over long range. For example, consider use cases like real-time asset tracking in warehouses, or being able to do remote temperature monitoring in buildings, or predictive maintenance of industrial equipment. All these use cases benefit from that long-range connectivity. And the alternatives that exist for this is wireless access technologies, let's say Bluetooth, Zigbee, Wi-Fi, which are unable to meet the long-range needs for such wireless applications, or not able to penetrate deep indoor environments for indoor use cases, like, for example, thick walls and floors of the buildings, in a multi-floor building, for instance. So the connectivity can be unreliable. And the alternative, which is cellular technology, can be power hungry and expensive while meeting the long range need, but they can be expensive because there is expensive connectivity hardware involved, and they could be high monthly access costs. So this is where LoRaWAN comes in, which is able to meet the needs of such long-range, low-power application requirements. The key characteristics that differentiates LoRaWAN is really its long-range, long battery life, low cost, and secure standard. So LoRaWAN can provide coverage over 1 to 3 miles in urban areas, and maybe even up to, up to 10 miles in line of sight in rural or remote areas. This enables those wireless IoT applications that we just discussed to benefit from that long-range coverage. So you can imagine applications like ride-sharing of bicycles, tracking, or reading data from utility meters, or predictive maintenance, or in oil rigs, or cattle tracking in fields. Indoor use cases like temperature monitoring or remote control of door locks. All these use cases benefit from that long-range coverage. Then, in addition to being long-range coverage, providing long-range coverage, a majority of these use cases, devices would need to send low amount of data, let's say every 5 to 10 minutes. And this low data rate for LoRaWAN sensors means that battery can last long, up to even 10 years in certain use cases. The third benefit is the low cost. LoRa nodes can be inexpensive. There is little to no battery replacement costs, which means customers save money and time on its maintenance. And lastly, which differentiates it, is the secure standard involved with LoRaWAN specification. LoRaWAN specification makes sure that only legitimate devices will be connected to the network, and checks that network traffic has not been altered, or ensures that network traffic cannot be listened to or captured. So those characteristics of long-range long battery life, low cost, and secure standard is what characterizes LoRaWAN.
Yeah, thank you. And we know there are quite a lot of use cases and the benefits of LoRaWAN. And how do we design the AWS IoT Core for LoRaWAN, and what are the benefits of AWS IoT Core for LoRaWAN?
So yeah, I'm very excited to share about AWS IoT Core for LoRaWAN, which we just released in general availability starting today. And as we designed the service to meet the needs of these long-range wireless IoT applications, we are bringing 4 key benefits with the service. First is fully managed LoRaWAN Network Server. And LoRaWAN Network Server is required to manage the devices and gateways connection to the cloud. Accelerated application development, ease of onboarding, and transparent consumption-based pricing that is cost-effective at scale. So I'll talk about each of those benefits a little bit more in detail. So with fully managed LNS, customers can enable cloud connectivity for their LoRaWAN devices for hundreds, thousands, or even millions of these devices with zero LoRaWAN network server setup involved. AWS IoT Core for LoRaWAN, in addition to providing a fully managed LoRaWAN network server, is integrated with LoRaWAN device provisioning and gateway management service. So customers can simply bring their devices and gateways and connect them with AWS IoT Core for LoRaWAN in a few simple steps using the console experience. The second benefit is the accelerated application development. We have built in an integration to automatically route messages from connected LoRaWAN devices to AWS IoT Rules Engine. Integration means that customers can act on the data from the connected devices using breadth of AWS services for processing, storage, analytics, or machine learning. Third is ease of onboarding. And we achieved that in 3 different ways. First of all, we ensured support for LoRaWAN standard specification, which means that customers can buy any compliant LoRaWAN device, sensor, or actuator without any requirement to modify embedded software and get a plug-and-play experience for connecting those LoRaWAN devices. We also are supporting an open source gateway software called LoRa Basic Station. And this enables customers to connect the gateway securely to AWS IoT Core and manage them remotely at scale. And to further simplify onboarding, we also launched AWS IoT Core for LoRaWAN hardware qualification program, which Karthik would talk more about. But this program brings the pre-tested gateways and starter kits from our manufacturing partners so that customers can get started easily. So those are the 3 different ways where we've made the onboarding setup easy. And the last benefit is the consumption-based pricing. Customers pay only for what they use, and this has been constant for all AWS IoT core features and services that capabilities that we have launched. And same with AWS IoT Core for LoRaWAN, customers will be charged by the number of messages sent to and from devices that use LoRaWAN specification and connect to IoT Core using this feature. So there are no monthly, yearly minimums, which means it's cost effective for customers at scale.
Yeah, great. And we see so many benefits from AWS IoT Core for LoRaWAN, including eliminate operation burden, accelerating IoT application development, and reducing onboard friction, etc. It's very great. And how can I get started with our AWS IoT Core for LoRaWAN? And you mentioned qualified hardware and also any other item to mention here? How to get started?
Right. So like I mentioned, we have enabled an easy onboarding experience with our console-based experience. So there are really 3 steps to get started. Register your device, register your gateway, and then set up a destination. And destination is a way for the connected LoRaWAN devices to to process messages using the IoT rules engine rule. So once you have set up a rule, you can map multiple LoRaWAN devices to the same IoT rule. And I would love to show a demo of how these 3 steps works in our console experience. So I'll share my screen to take you through that onboarding experience on the AWS Management Console. Here you go. All right, so this is the landing page for AWS Management Console. And once you are here, you can start off by searching for LoRa or LoRaWAN, and you would see our service show up. So you can search for LoRa, you can even search for LoRaWAN, or let's say wireless, you'd see AWS IoT Core for LoRaWAN. So you can click on that link and it brings you to the landing page for the service. Here, you can learn a little bit more about what AWS IoT Core for LoRaWAN offers in terms of the key terminology that we use in our onboarding experience and overall experience, the benefits and features, the use cases. And on the right, you would see a button for getting started. So you can just click that button and land up into the onboarding experience. You'd see View Gateway over here. This is because I had already added Gateway. But if you were to come here for the first time, you would see an Add Gateway button in orange, similar to the one that you see on the right for Add Device. So you can just click that Add Gateway button to get started. So as you would click that button, you would land up into the registering gateway step, which is the first step. And you'd see the first thing you need to do is provide the unique identifier for the gateway. This is specific to the hardware that you are trying to connect and is provided typically by your manufacturer. So it's written on the back of the hardware, or it's provided in some guide. So you can input that. Select your frequency band. So I'm connecting it in the US, so I selected the US 915 frequency band. And then I give it some name, which will help me identify the gateway as I create and onboard multiple gateways. Description, again, it helps you identify the gateway. With association with thing, you would see that it brings the capability of IoT Core to AWS IoT Core for LoRaWAN. So as you're registering your gateway, you can associate it with AWS IoT Thing. And what that will help you with is things like you want to align the access control for your wireless gateway with the thing that it is associated with, or you want to have all the messages from your gateway to be tagged with the same billing group, which is associated with your thing. So those kind of features would allow you, you'd benefit from them if you enable this association. So that's where it's useful.
Great.
And then lastly, you would see tags on the below the thing association. And again, tags, like I mentioned, you are able to tag things, the gateways with the corresponding thing billing group. So for example, you have multiple customers, so you can create tags like cost allocation and assign values specific to a customer. On to the next step, here you would see the credentials that you would need to upload on your gateway so that it can authenticate with AWS IoT Core. So you can generate those certificate and private key, which you then will be able to upload on your gateway UI through the gateway vendor provided interface. Here are the provisioning credential for the AWS IoT endpoint, again, which you will be configuring on your gateway using the manufacturer provided endpoint. So let's say you use the configuration and update server endpoint, you can copy it so that you can put it into the gateway UI later. And thirdly, I want to call out the gateway permission step, which is that if you're using CUPS endpoint to onboard your gateway, then you would need to set up an IAM role. And I will talk about this a little bit more in detail later. And after you have gathered these credentials, what you can now do is go to your gateway vendor provided interface, log into the gateway's local network, upload the certificates that you just generated on this page, the server trust cert, the gateway cert, and the private key, and the endpoint that you copied from this screen, the CUPS endpoint or the LNS endpoint, depending upon the endpoint that's supported by your gateway, and then configure them on the gateway. And once you do that, you should be able to see the gateway connection established. But even, let's say, before that, after you finish this step and hit submit, you would see the gateway connected, registered in AWS IoT Core for LoRaWAN. Next, you would go on to the step of registering the device. And as you can see, for LoRaWAN devices, you would it's a combination of picking the authentication process and the LoRaWAN specification version. So there are 4 different variations that are possible. So you'll pick the right one depending upon what kind of device you are onboarding. So in this particular case, let's say we selected over-the-air activation way of provisioning and LoRaWAN specification version 1.0. So I made that selection into the UI. And then I'm able to input the unique identifier and the security keys for that hardware. So again, this is provided by the the vendor and is typically included in the guide or on the hardware. So you would have received it from your vendor. So you can input those security keys into the UI. And the security keys or the combination of keys you'll provide will vary depending upon the type of hardware you chose, the type of provisioning and specification version you chose. Again, you can name the device because this will help you identify the device later on, and then associate a thing with your wireless device. On this step, you will select a default a device profile to associate with your device. And device profile allow you to define the supported data rates, channels, and other settings which will be used when the LoRaWAN Network Server or AWS IoT Core for LoRaWAN in this case communicates back to the device. And there are different combination of default device profiles that we have created for you to enable ease of onboarding. So you'll see different combination of frequency bands, different classes of devices, A, B, and C, which are supported by LoRaWAN, and different, the OTA version. The OTA is the method of provisioning. So you can select one of these default device profiles if your hardware supports one of this combination. If not, you can always create a new device profile from scratch. In this particular case, I made the selection of US 915 Class B. So you'd see those parameters that we have created by default, but you could always alter them using if you wanted to create a new profile from scratch. And lastly, you'd be able to select and attach a service profile to the device, which allows your gateway to send the metadata for the device. And this is the last step. You have registered your gateway, you have registered your device, and now you are ready to set up a destination. Setting up a destination requires you to set up an IAM role, and I'll talk about this a little bit more in detail. But you select the IAM role so that it allows AWS IoT Core for LoRaWAN to publish on behalf of your device to AWS IoT Rules Engine. You define the destination name, which is, let's say, I'm building a temperature application, temperature tracking application. So I give that name. I set up a rule name, which is what is it, the kind of action that I will be taking with the data that I get from the devices. And you'll be able to set up this rule that you map to this device in IoT Rules engine later. Or you could have put in a rule name for a rule that you may already have set up. But if not, you can create it later. So that finishes your gateway registration, device registration, and setting up of the destination. At this point, I wanted to take you to two different IAM roles that you had to create in order to finish that getting started experience. The first one was the IoT Wireless Gateway IAM role. So this role was required so that the configuration and update server, the CUPS server, is able to generate the certificates as part of the basic station protocol and deliver it to your gateway. So in the gateway onboarding step, when your gateway will communicate with the CUPS endpoint, AWS IoT Core for LoRaWAN would require to assume this IAM role on behalf of you and to give the right permissions to the CUPS server. So that's why you would need to create this IAM role before you can fully register the gateway correctly. And it would be best if you were to create this IAM role before the step of registering the gateway. And similarly, there is a second IAM role. I took you through that experience, which was required during the setting up of destination step. And similar to this one, that IAM role is required to give permissions to describe the IoT endpoint and to deliver your messages to IoT cloud. And once you have created these two IAM roles, going through the getting started experience should be straightforward. So with that, I'll hand it over back to you, Bo.
Yeah, thank you. It's very clear and step-by-step demos. And for next part, we will talking about the ecosystem for AWS IoT Core for LoRaWAN. As we know, ecosystem is quite important for IoT. And I'd like to ask Karthik a question. And can you tell a little bit more about AWS IoT Core for LoRaWAN hardware qualification program?
Yeah, sure. Thanks, Yubo. So the AWS Device Qualification Program is designed to help customers to find hardware which is compatible with different AWS services. So what it involves is hardware partners integrating the required AWS or compatible capabilities into their hardware. And then after that, it goes through a rigorous testing by both AWS and the partner to ensure that we have a robust and secure implementation, which customers can have confidence will work with the AWS services. Once that's complete, the hardware is listed into the AWS device catalog, where customers can filter, browse, and find the most appropriate hardware for their use case. So we're pleased to announce that for AWS IoT Core for LoRaWAN, AWS has qualified 12 gateways from 5 different partners. These are Multitech, Curlink, Tectelic, Browan, and Laird. There are many choices for gateways, ranging from low-cost indoor gateways that may be run using microcontrollers, all the way to robust outdoor gateways with cavity filters designed to work in harsh environments. The number of gateways we've qualified provides a breadth of different offerings that customers can choose from. So the qualified gateways and starter kits are pre-tested to make sure that they meet the basic station software requirements, which Priyanka mentioned. And they also include a step-by-step guide for the manufacturer to help the customer on how to connect it to AWS IoT Core for LoRaWAN. So this is following through on some of the steps which Priyanka mentioned, where you get the credentials and you want to input those into the gateway. Those are going to be specific for each gateway vendor. So those getting started guides that are provided that are in the catalog will walk the customer on how to do that provisioning step. And finally, the starter kits that are provided also include the additional information on how to take the data from that sensor and do something useful with it, such as sending the data as a text to a mobile phone using Amazon SNS service, or visualizing that data in a cloud dashboard using Amazon QuickSight. So all the qualified hardware that I mentioned today can be purchased online. We have a single distributor, CalChip Connected, who carries all of those products today. And of course, AWS will continue to work with additional hardware partners in the future to offer an increased selection of gateways.
Okay, thank you. And besides hardware qualification, how are we enabling a partner ecosystem such as SI partners or solution starter kits?
Yeah, that's a great question. So to enable customers to help build a product and bring it to market based on AWS IoT Core for LoRaWAN, we've worked with 3 leading system integrators, Clickatek, Tensor IoT, and Leverage. All 3 SIs were part of the beta program for AWS IoT Core for LoRaWAN, and these partners are very familiar with how the feature works, how to connect gateways, how to ingest data from sensors, and how to build a complete application using AWS IoT. So these SIs offer design and integration engineering services to help customers quickly build end-to-end applications that utilize the new AWS IoT Core for LoRaWAN service. Finally, I wanted to add, we also collaborated with Tensor IoT and Semtech to create 2 LoRaWAN solution starter kits. So these kits are targeted at customers who want to quickly deploy sensors and get to a proof of concept using the AWS IoT Core for LoRaWAN services. So the solution starter kits provide a cloud-hosted dashboard that uses AWS IoT Core under the hood. And the smart building kit that we have, that one contains a variety of sensors from BroWAN Communications. When these include sensors like temperature, humidity, leak detection, desk and room occupancy, as well as people counting sensors. The kit also includes the LoRaWAN gateways that are needed, as well as a Wi-Fi hotspot, so customers don't have to worry about connecting to their corporate networks. The asset tracking kit includes an outdoor rated LoRaWAN gateway, and it also includes 6 industrial trackers, which are also provided by BroWAN. So together, the kits enable you to connect the trackers, track your assets on a map, all provided in a cloud dashboard. And these kits are actually available today for purchase from Mouser, DigiKey, and Amazon.com.
Okay, thank you. As we are running out of time, and let me ask a final question about customer stories. As we talking about AWS IoT Core brings so many benefits to LoRaWAN, and can you share some customer stories for our LoRaWAN services?
Yeah, absolutely. There's 2 customer stories which I'd like to share. The first one is Compliance Mate, who's focused on food safety applications. So today, most restaurants use notebooks and clipboards for compliance checks. Compliance Mate is changing that. They offer a solution that addresses the critical need for proactive food safety at restaurants. Too many hospitality brands operate without a comprehensive temperature monitoring and hazard analysis critical control point, or HACCP, as it's known in the industry, compliance system. As a result, they're putting guests at risk every day. They're also forfeiting a major opportunity to keep staff accountable, reduce food waste, and maintain brand integrity. Compliance Mate is using AWS IoT Core for LoRaWAN to connect temperature sensors in restaurant refrigeration and freezer units. These are cold climate sensors, and they're leverage devices that have low power and long-range wide area network to penetrate through those deep freezer and deep cold storage units. They can penetrate the thick walls, and they can last for years without replacing the battery, thanks to the low power consumption associated with LoRaWAN. Using AWS IoT Core for LoRaWAN allows them to more easily meet their customer goal of ensuring customer food safety while reducing the risk of food perishing. The second example I'd like to talk about is a customer, Quext, who's focused on providing tenants and apartment owners with a better experience. They do that by deploying smart thermostat and door locks, which provide tenants with a smart home experience out of the box to better control their security and access to property, as well as having better control of their climate, reducing their power bill. The thermostats on the property connect to a single LoRaWAN gateway, which uses cellular or existing backhaul to connect to AWS IoT Core for LoRaWAN. The result is the solution provides building owners with better operational efficiency and security by enabling them to turn down the HVAC when tenants vacate a property and be able to give contractors fine-grained control of the property for things like repair and maintenance. Overall, Quext customers were able to see a $25 per tenant per month uplift from deploying the solution.
Okay, thank you. Through this session, we learned a lot about AWS IoT Core for LoRaWAN. And thank you for joining us. And thank you, Priyanka and Karthik. See you.
Thank you.